Alright, hello and welcome. My name is Ilya Tetin and we are going to study Introduction to Deep Learning this semester. So this semester is a really natural continuation of machine learning. We are going to cover a vast set of topics on neural networks, on dealing with different types of neural networks, from regular one FC fully connected convolution neural networks, RNN, LSTM, transformer architecture, to different applications such as images generations, images segmentation, and other types of applications. So let's go through the syllabus real quick. First, we are going to cover the FCNNs and how they are going to be developed in PyTorch. PyTorch is a framework that we are going to use extensively. There are several possible ways of learning in programming neural networks, like TensorFlow or PyTorch, which are most popular ones. And let's say 5 years ago, TensorFlow was more popular than PyTorch, but in time Google just decided to stop developing it and turned to JAX framework. But JAX is not that popular as PyTorch. So at this moment we are going to study PyTorch because it's like the de facto standard, and the majority of applications and new architectures are developing in this framework, and it's really nice to cover the most popular and the most useful, very convenient one, in order to understand what's going on inside the neural network and how it trains, and how can we extract the information from the training. Alright, so we are going to cover this PyTorch, and we will be introducing several homeworks here, and the first homework will be immediately in the lecture after lecture 2. The first homework on PyTorch, on scikit-learn. So the homework will cover tensors, building blocks of PyTorch. We're going to compare the performance of logistic regression and networks on tabular data. We are going to implement a gradient descent. Then we move on to convolution neural networks, and there will be another homework 2, where we're going to predict the release year of a song. This one is a regression task based on audio features. Later we cover extensively different architectures of neural networks, starting from basic one introduced by Jan LeCun 1998, to AlexNet, VGG, ResNets, different efficient nets, mobile nets, and all these modern architectures. After, we will introduce the task of image detection and image segmentation, and cover UNet architecture. And there will be another homework 3, on image classification. At the moment, as we cover lecture 6 and homework 4 on object detection, we are going to place it in week 8, I believe. Alright, so week 9 there will be a midterm. A midterm will be a written one, like the final exam, also a written one. You are not going to use computers, you're going to have only pen and a piece of paper. So there will be several questions where you have to write your opinion, describe something, and provide the maybe computational graph or some drawing of neural net architecture. After midterm, let me state that midterm and final exams, they are only worth 10%, so it's okay if if you don't pass them on 100%. It's okay, they're worth not much. Each homework, and there will be 8 homeworks, worth the same 10%. So overall 8 homeworks give us 80%. And after midterm we will start natural language processing. So there are actually 2 paths in teaching deep learning, and the first path is just to cover CV and NLP, and the second path, which I prefer, is to introduce you to different applications of deep learning, like the generative adversarial networks, like audio processing, and I think that it will be much more useful for you just to get the understanding of different applications and different possibilities that neural networks are allow you to use to gain significant advantage in different tasks. Okay, so natural language processing, the word to vec, where we are going to have the vector representations of words, then LSTM and RNN, so recurrent neural networks and long-short-term memory architectures, we are going to cover them, and homework 5 on RNN and for text generation. So we are going to generate text. Then there will be a wonderful topic on transformers, week 12, transformers, introduction to transformers, as well as the seminar. So in 2017 there appeared a paper which is called Attention is All You Need, which opened the door to using attention, self-attention, and introduced the transformer architecture, which actually changed the landscape of understanding of language, and significantly moved forward the overall progress in artificial intelligence. So the transformer architecture is quite useful, and you are going to build your transformer for text generation as well. This will be homework 6. Homework 7 will be on GANs, generative adversarial networks. We will cover GANs and diffusion models, and you are going to deal with the task of particle generations, particles of physical elementary particles. So you are going to generate images of them. Next, there will be an audio analysis, audio recognition, and it's again one of the greatest possibilities for you to just understand how the neural networks capable of understanding the audio tracks, and you're going to deal with the homework on implementing RNNs and CNNs for audio track classification. So overall, I think that 80% for the homeworks is quite quite vast. You can have a bonus, just like we have had a bonus of 10% in our machine learning. So overall, midterm, final exam 10%, 8 homeworks 80%. Once again, there will be the soft and hard deadlines. They will be announced in front, so you are capable in submitting the homework before the soft deadline without any deduction. And each day, starting from the first second past the soft deadline, first 24 hours is minus 10%, another day minus 20%, another day minus 30%, and so on. And you are allowed to postpone the deadline twice per semester. So 2 times per semester, you just decide on which homework you are going to postpone, and you have to submit it before the hard deadline. Then twice in semester you won't get any deduction of the points. Basically, what you are going to need for covering the topic of deep learning, there are Colab, Google Colab. It allows you to exploit GPUs. So if you start the new notebook, you will have to connect and change runtime type, and you'll have the ability to use the T4 GPU. It allows you to use several hours of that, particularly 2.5 hours or 3 hours per session, and that should be enough for basic training. Besides that, there is also a Kaggle platform, and inside the Kaggle you will have an ability to create a notebook and use the GPU from that notebook. It's a little bit faster, so there might be 2 options, like using the 2 GPUs at the same time, 2 T4s, and alternatively P100, quite nice GPU. Again, they are much more capable. They have 16 gigabytes of video memory, which is more than enough to load our networks there. Kaggle allow you to utilize GPU for 30 hours per week, which is more than enough for training and experimenting with your homeworks. So if you don't have a GPU on your computer, there is a possibility for experimenting on a smaller set of data. Just select several classes. Like in homework 3, we're going to produce the image classification in 200 classes. So you have to select several classes, like 5 or 10, select several dozens of images, build your architecture, test it with your CPU. Even in the notebook it should be fine, and if you're feeling that the architecture is good, just extend it for 200 classes, make proper training for all the data sets files that you have, and proceed to Colab, use T4, or proceed to Kaggle, use P100, and you'll be fine. Alright, so once again, PyTorch has a lot of interesting tutorials, very nice help, very nice documentation here, so please use it. It's really beneficial for you just to understand what's going on here. Like let's say the transforms, and you'll see that there are lots of models of transformations, of even using the transformer architecture, different types of optimizers, everything that you're going to need in order to be succeeded. So let's say you need to understand how the Atom Optimizer works. Here are the parameters that you might optimize there. If you need to get into the details of what's going on, there is the pretty much good source code for any of the internal thing. There are explanations, there are examples of how you're going to implement. Here, let's say, the state dictionary for that, and so on and so forth. And there are, besides the documentation, there are tutorials that you might use in order to be capable of understanding of how to deal with the homeworks. So besides PyTorch, besides links for documentation for the PyTorch, generally, if you are using anything besides that, you must state it explicitly in the homework. So let's say that you have Googled something, let's say, why am I my CNN not learning, something like that, and you're going to Stack Overflow, then you must provide this particular, let's say if you are using some code, if you copied this code, you need to state that you have copied this code from this particular link. If you are using some code from the GitHub, then again you must provide a link from the GitHub to specific place where you use that code. Without that, if I see that you and maybe one of your classmates use the same code, that means you have plagiarized this code. And plagiarism is strictly prohibited. And if I see that you're using the same code, like the very similar solutions, that means that you get 0 for this homework, both you and your classmate. Do not distinguish on who copied from whom. I just think that you break the behavior, and you have to bear the consequences of that. So in order to be okay, provide the link. Okay, so what else can I say? There are different textbooks that you might use. Let's say 10 best books on DL. And what can I see here? Deep learning with Python is okay. Deep learning with Python is okay. You can use that book. I recommend learning on the deep learning from Ian Goodfellow and others. Very nicely written book, good language. Deep learning from FastAI and PyTorch, I'm not sure about that, but there is a separate book with Manning Publishing. There is actually this one, the second book, Deep Learning with PyTorch, with a different picture, from Manning Publishing. I recommend reading it. And those books are generally available in the internet, but if you can find them in the library or in Amazon, maybe it's worth buying, and I recommend buying them. But Ian Goodfellow book actually is available definitely for free. It's written by MIT university professors, so freely available. Use it, try the examples from there, and read it extensively before midterm and the final in order to be good at midterm and the final. Alright, Hope that you'll be fine with your syllabus. We are going to cover a lot through this semester. There will be several mathematical applications by calculating derivatives. Besides that, programming, application of basic principles of machine learning. You need just to understand what does it mean to train the neural network, how to optimize, what gradient descent means, some basic principles of testing, validation, data sets, why they are needed. If you know that, you're perfectly fine. If you don't know that, we will just reiterate and I'll remind you on all this stuff, and hope you will enjoy this course and you'll be successful in your future careers. Thanks for watching and see you in class.